I'm Ian Puckett,
And this is
physics, work, and a plethora of vocabulary words. Beginning with work. Work is done when a force that is applied to an object moves said object.
Using this paper we stole from a guy who works at Best Buy, we can calculate work. So to revisit the paper we stole from the employee at Best Buy, the equation for work equals force times the distance traveled. And this massage chair right now is putting in 10 times the work that your employee up here does.
This massage chair wouldn't take my money.
We're here in the middle of Dick's Sporting Goods and we're about to calculate for work. We have distance, which is 10 feet. And we have work, which is level 100.
Now, we're going to do some work. Working this equation. So here I'm holding this here. It's an Italian name, I can't really pronounce it. It's just a really nice pen. So what we're going to do is, over here, we're going to start the equation. So it's W. I would like you to come over here now, like right here. There you go. This is not a blooper, this is really happening. So, W equals F D.
That's an awful F.
That's not how I really write my letters, shut up. So now we have W equaling 100, parentheses, 100 equals F, and distance being 10 feet. So now we're going to divide 10, divide 10, and now you're left with 100 divided by 10, equaling 10, which would then be 10 equals F. There you go, that's an F right there. And that is how you physics. Now it's time to give examples of work.
A great example of work are these two bomb cowboy hats, mine American flag, and Ian's ridiculously printed one.
Now let's go look at other stuff.
Today on National Geographic, we are in Spencer's. Please observe this employee wearing sweatpants. Hideous sketches. It's incendiary. Do you know what else is incendiary? The amount of work he's putting in. Truly admirable.
Another example of work is walking around the mall with Hannah Murphy. That's a take.
An example of work is bungee jumping. Look at Dylan putting in this work. Delta X, Delta Y, negative 9.81, gravity, physics, bungee jumping.
That's a whole lot of work.
Another example of work will be the work that Mike Cullen will be putting in after I demolish this candy bag consisting of Dr. Pepper jelly beans, A&W root beer jelly beans, champagne jelly beans, Mike and Ike's, and Skittles. Another example of work is working with mall employees.
Oh God, here we go. I've been terrified to work here. So seeing as how we were thrown out a hot topic by a rude employee, we decided to try Charlotte Roofs. What's up, man? What's going on this club? Look at this employee. Hi, man. How are you?
Good, how about you?
Good. How would you define work?
Work is what you have to do to achieve your goals.
That's the take.
I'm here with Michelle, this Thanks Remembered Personalized Gift employee. Michelle, can you please define work for us?
It's very boring and lame.
Thank you. Our next stop, A&A Boutique. Here at A&A Boutique in Cooper, Kentucky, joined by
Kelsey Jones.
I was wondering, Kelsey, could you please define work for us?
That's what I'm doing right now.
I'm Puckett and Dylan Jones here at Go Games, Calendars, and Toy Store in Paducah, Kentucky. We're joined by this Tyrannosaurus Rex here. If you're
What's his
wondering,
name? What's his name?
Mr. Rex. Mr. Rex, can you please define physics for us? How about work?
Yep.
Splendid.
Couldn't have said it any better myself.
And now we're going to begin defining vocabulary words, and we're going to be giving examples of each vocabulary word listed. Beginning with work. Work is done when a force applied to an object moves said object, when the force being applied and the object being acted on move in the same direction. In this example, the object being acted on is the lawnmower, and the force is being applied by the man. So, the man is doing work on the lawnmower. Next is force. In this example, this devilishly handsome young man is nonchalantly carrying his highly overpriced organic coffee with him to his job at an environmental law firm. Notice there is no work being done because this man is applying force by acting against gravity to hold up his cup, and the cup is moving in a positive direction. This is an example of force. Next up on our vocabulary list is kinetic energy. In the picture listed, please observe America's cranky mother-in-law, Hillary Clinton, holding up this Nike Free Run. Nike Free Run's the choice of American runners, and Nike Free Runs are used, well, to run. And unlike the sickly Mrs. Clinton, this sprinter is vibrant, tenacious, unforgiving, relentless. Wearing Nike Free Runs, you get the picture. The point is that he is in motion. Energy that is in motion is defined as kinetic energy. So, the sprinter pictured is an example of kinetic energy. Next up is velocity. As you can tell, these two daunting young men are running away from a rather large train that has the potential to end their very existence. Be that as it may, we're only concerned about the science of this scenario. These boys are running at a speed of 20 kilometers per hour in the north direction. Velocity is defined as the speed of something in a given direction. Next up on the list is mechanical energy. This construction worker pictured, who I'm going to assume is named Ernest, but in a futile attempt to impress his construction worker buddies adopted the nickname Russ, is hitting a nail. Mechanical energy is the sum of potential energy and kinetic energy. Potential energy is simply defined as energy in a body at a certain position. So for example, when Russ holds the hammer and is not swinging it, the hammer has potential energy because it's sitting still, so to speak. Kinetic energy has been defined earlier in the video that all of you wish would just come to an end, as energy in motion. So when potential energy and kinetic energy combine and the hammer cracks down on the nail, that is mechanical energy because it's the sum of kinetic and potential energy. Next is gravitational potential energy, which is defined as the energy an object possesses because of its position in a gravitational field. This beam is an example of potential energy, seeing as how it's not in motion, and it's in a gravitational field because if it were dropped, it would be in free fall. This beam is an example of gravitational potential energy because it is not in motion and it is in a gravitational field. Next is elastic potential energy, defined as potential energy stored as a result of deformation of an elastic object. Example, stretching of a spring, like the one pictured. Next is the law of conservation of energy, discovered by Sir Isaac Newton. It states that energy cannot be created or destroyed, but only that it changes forms. Next, we have thermal energy, energy that comes from heat. This mixtape is fire. It gives off thermal energy. And there you have it, thermal energy. Next, we have power, which is defined as the rate of doing work. Also, watts are the unit used to measure power, similar to joules, which will be covered next. Joules are defined as the unit that is used to measure energy, like these here shock pads. Next is work kinetic energy theorem, which is used to find the change in kinetic energy. It reads as net work, which is the sum of all forces and work, equals change in kinetic energy. And next is spring constant, which states that a spring is directly proportional to the distance you stretch it. As an equation it reads F equals Kx, where F is the force we apply, K is the spring constant, and X is the extension of the material, typically measured in meters.
Oh, I didn't see you there. Hi, I'm Ian Puckett, and what you guys just witnessed was an absolute eyesore. And we thank you for being troopers. Now, here's something we hope you'll really like.
Everybody be quiet, we're hunting rabbits.
Please join us in an hour of National Geographic and Spencer's. Notice this guy working at the counter. All the work he's putting in amidst those sweatpants and
Now let's give you guys some example of work. Another great example of to define work. Next, we're in Dick's Sporting Goods. We'll be throwing this football. We're going to calculate work. We have F and we have D. We have W and D, not F.
We're in Dick's Sporting Goods right now, and we're going to try to find for work. Alright, so we have distance, which is 10 feet.
Check.
Check.
Then we have work, which is 100 joules.
Not yet,
Check.
you gotta throw it. We're in Dick's Sporting Goods right now. We're about to calculate for work. We have distance, which is 10 feet. We're in Dick's Sporting Goods and we're about to calculate for work. We have distance, which is 10 feet. Well, yeah, we're here in the middle of Dick's Sporting Goods and we're about to calculate for work. We have distance, which is 10 feet.
A and ABT.
Look at Ian putting in this work.
Hello, my name is Ian Puckett, and what you just witnessed was an obscenity of a video. So,
Try to.
You didn't go.